demonstration of DC motor driver using HBridge VNH7070AS, which is automotive grade. My name is Jaykumar Sengotivel. I will walk you through this presentation. This is a picture of the evaluation board and its schematic and typical application schematic. The setup requires a couple of digital output from the microcontroller and a PWM output for drive control and analog input pin for current sense and fault monitoring. The voltage across this R sense is a current mirror of the whole load actually being driven by a selected leg. Let's look at the Simulink model. This Simulink model drives a couple of PWM the digital output and a PWM pin, and it also reads the current sense output from the HBridge, the voltage across R sense. This little scope here has two sections. One on the top shows the raw reading, while the bottom one shows the filtered one. This little window here can be used to control the PWM frequency on the duty cycle. The lab power supply has a display which shows voltage and the current. The multimeter shows the actual PWM frequency. Now it's a 16 kHz. Let's drive the motor. Now we see the current shoots up and comes down and then stabilize at this point. And let's increase the speed of the motor by increasing the duty cycle, and we see the current is going up, and we see the display on the Simulink corresponds to the current display on the lab power supply. Let's stop the motor and observe the current. Yeah, it's 0. Let's drive the motor 100% duty cycle. Yeah, it's high. And then let's drive down to 75%. Yes, and decrease again. So now we see the control is working fine. Now let's look at one of the interesting factor, the noises around the measured signal. So the raw reading shows a lot of noise while the filtered one looks more stable. This is fine with a high frequency like a 16 kHz or 20 kHz, but as we come down to 500 Hz, we see a lot of oscillations in the measured current, and also the average also does not useful. And let's increase to 1000 Hz. It's still the same. 5 kHz. Yeah, it's good. The noise level is less. And when we go to 10 kHz, it's much better. Things like 16 kHz, the frequencies like 16 kHz looks pretty good and does not require any additional filtering. If you want to do the current measurement with switching frequency like 500 Hz, probably we need an additional RC filter. That concludes the presentation. Thanks for watching.